Good morning, everyone. Welcome to the EasyPower Tuesday morning refresher. This is Jim Chastain with the Support Engineering Group at EasyPower, and we welcome you all to this edition of refresher, which will be focused on utilizing the Scenario Manager utility in EasyPower, a very useful tool that, with just a little bit of attention to a couple rules, can expand your capabilities, I think, and productivity as far as your workflow. So I encourage you to try it out after we go through this presentation. Scenario Manager was developed to work with several different modules in EasyPower, including Power Flow, Short Circuit, and Arc Flash, and the Harmonic modules. What it allows us to do is to add, remove, or modify equipment in the one line and then be able to compare the results and save that the alternative configuration for future reference and not modify or not make any changes to the actual base case. It also allows us to change the normal position of breakers and switches and then zoom or change the viewing window for various reasons, and these I think you can use for your particular needs to bring attention to some area of the circuit that you're trying to focus on. Also, in Short Circuit, automatically Scenario Manager generates reports that compare arc flash incident energy for each of the scenarios and each of the buses in the one line, and at the same time will create or can create the worst case incident energy list, showing in the list of buses only the ones that are the worst case. Likewise, for equipment duty, the tool can automatically generate a comparison of each of the scenarios for those calculations, and likewise the list of worst case. So it makes that chore of calculating and comparing considerably easier in the long run, saving potentially hours of time based upon what you're trying to do. This, as I mentioned, is a utility built into Database Editor, and it allows us to select from a list of scenarios which items are to be compared against the base case without changing the base case itself. So what we're going to do is run through a couple examples. One is specifically in Short Circuit, comparing different configurations of a one line and then doing the arc flash calculations. And the second is to go through a what if scenario in Power Flow and compare some options that we have when we're trying to make some modifications to our system. So let's jump in the tools and see how everything looks. I do want to mention that from the users page, you can call up the start page, you can call up the user's guide, and from there you can search or find a Scenario Manager chapter in the manual and make fairly quick work of getting to the details of any part of the system, any part of the rules and regulations as far as using Scenario Manager. So there's a whole chapter on it, and I invite you to kind of zero in on that and check it out for yourself. Looks like it's on page 305. So you get the idea. All right, so the example that I want to look at is one I have open here, which is kind of a complicated radial system that has both utility and cogen support, and then the ability to cross-connect several different configurations, all of which we need to calculate incident energy for, and then come up with the worst case. You'll see as we go in and look at the current list of scenarios, and now this is one of the places that I talked about a rule. Because the tool is sensitive to change in zoom and window viewing, the only thing I've done to this one line so far is just slide it over a little bit and zoom in a little. And so it's asking me if I want to change. Actually, I don't, so I'm going to say continue. And now it's going to show me the list of pre-existing or the scenarios I've already defined. So if we pick out cogen only tie closed and open it up, you'll see that, and let me zoom in just a little bit. Here we've got the utility side isolated with these two breakers. The cogen is supplying now with the tie breaker closed. So to indicate the differences between the base case and this particular scenario, we have color-coded these two high voltage breakers and this low voltage breaker along with the tie breaker to indicate what's different from the base case. Again, I've zoomed in, so now as I try to go to the next scenario by opening, I don't want to change this one, so I'm going to say no. Let's go ahead and pick out cogen tie open. And again, we have our utility breaker closed and our tie breaker open, which is normal case for the tie breaker. But now with this utility breaker open, we're supplying both sides through the common bus with the cogen, and clearly that could make a difference in our calculation of incident energy. All right, so I want to add to my base case. Let's go back to the scenario manager, open the base case, don't save anything. One of the conditions that IEEE recommends checking out when you're doing incident energy calculation is with no motor contribution. I'm place the cursor in an open area of the one line and right click, and part of this list includes a checkbox that says include motor contribution. So without changing anything, I'm going to go to my short circuit focus, fault all the buses, look at half cycle current, and I can see plainly that I have motor contribution coming back from each of these motor control centers and nothing going on in the panel, which indicates there's motors here and the motor contribution is being part of the calculations. So I want to make sure I calculate or generate a case that includes no motor contribution. So I'm going to say new scenario. Let's don't change anything. I'm going to right click out in the open area, uncheck this box, go ahead and look at short circuit, fault the buses, look at the current, and now I can verify I have no motor contribution. So I'm going to save, go back to database editor. I'm not going to save anything in the database yet. I want to name this store scenario as without motors. Now as I go back to my base case and I look at my scenarios, now I've got my without motors as part of the list. All right, so now what I want to do is calculate my incident energy comparing all of these different scenarios. To do that, I go into my scenario manager pull down, create scenario comparison report, select arc flash. Now each of these scenarios is created with a macro, and since the base case is the same derivative or the same basis for all these calculations, the tool as it's going through the calculations just applies a macro for each scenario so it knows what the differences will be. So we're going to create a report with a default form, and what we see now is a list of all the different buses. All right, here's bus ATS, MV, swing bus, switchgear A, switchgear B, and the like, and it's indicating the worst case of the scenario. So here's panel B3 on standby is the worst case for the bus ATS. whereas the base case is the worst case for the MV bus, cogen only, tie open. So you can see now it's giving me a breakdown of which scenario or which bus is worse for that particular scenario. Likewise, I can go up and by selecting this top icon next to the left, illustrate just the worst scenarios. And now from here, this bus has a worst case when we apply the panel B3 on standby. This bus, panel B3, is the worst on panel 3 standby, which on the standby generator, which is kind of what we would have guessed. And from here we can print the labels. So we can print the worst for all buses and we're off and running, if that's what we want to do. All right, so I'm done with this and we're ready to jump into the second case. Now my second case is this PV farm, and turns out we need to add a motor to be applied in this particular location. It's going to be a large motor, and we have a choice of putting it on the DC side or on the AC side of the system, and we want to see what the trade-offs are in that case. Now clearly this is not an example on how to design motor controllers or motor additions. We're strictly just illustrating how to utilize the scenario manager to look at our what-if comparisons for what seems like a fairly novel idea, novel configuration. And for this case, we'll be looking at the power flow for the bus. So right now, when we look at power flow and solve our equations, we see that we have a generation of about 1/4 of a megawatt. If I right-click in an open area and look at my power flow options, one-line output, we're showing branch flows in megawatts and megavars, generation and loads in megawatts and megavars. So we're generating a little over 1/4 megawatt and not really doing much with some reactive power that looks like it's probably being absorbed or utilized to run the transformer. All right, so what I want to do is generate two scenarios, one where I add the 500 horsepower motor to the DC bus, and one where I add it to the AC bus. Now what that means is this. In database edit, I'm going to create a new scenario. We're not going to save anything because it's just the zooming and panning that I've done so far. In which case we're going to add a motor and a switch. Again, we're not designing a real system, we're just trying to look at overall variables that we may have to deal with by adding the motor of this size on one side of the system or the other. And so just for grins, I'm going to put a capacitor here that we can play with later. And for now, we're going to not even keep it in the system, so it doesn't have to be specified. All right, so we're going to make it a variable frequency drive because we want to save electricity. It's going to be a 500 horsepower. We're going to calculate the X over R. TCC will probably plot at some point in time. Power flow, we're going to run this thing at about 14%. And motor starting, we'll calculate the horsepower kVA ratio. And now because we do want to make it, and I want to go back to my specification, we did make it a VFD. We're going to pull up the harmonic content from a typical industrial controller, pulse width modulated 14 or 15%, and import that data. All right, let's go ahead and save this as our AC motor. So we're going to store scenario as. Let's go ahead and go back to our baseline. And here we're going to start another scenario and add a 500 horsepower motor on this side of the fence. Now this is not necessarily something you would want to do. I'm just looking at the comparison between the two. All right, so just kind of pulling some numbers out of the air. Let's say this is a 500 horsepower. Our armature current we expect to be 25 amps or so. And let's say our impedance or our resistance is 6.8 ohms. Probably going to run about 300 RPM. Let's say 500 RPM. And that's what the comparison we want to do. So we're going to save this scenario as a DC motor. And since it's DC, I'm not going to worry about harmonics, although we can look at it when we want to. So let's go ahead and look at our power flow. And we see that we, by putting this motor online, we basically suck up all the power created and then some from our DC generators from our PV farm, because we're drawing now 141 kilowatts. So maybe that's not such a good idea. Let's go back to our database editor, change our scenario. Let's go ahead and save the one we got. And let's open up the AC motor and go ahead and go into power flow. Solve this. So now here, with this configuration, we see like we're still generating, or we're still able to produce 230 or so megawatts, kilowatts, but we're drawing more reactive current, which you'd expect. The question is what kind of a penalty are we going to pay in harmonics? So let's look at that, and by going in the harmonic focus and picking out this particular bus and looking at our bar chart, we see that there's some harmonic content, but it looks relatively small. Let's go back and look at our all sources. So we're showing up with less than 1.6% total voltage distortion, and I think we're looking at current. If we look at our harmonic options, one-line output, our branch current is per unit flow, so we're looking at 0.7 per unit. So it looks relatively benign as far as the harmonic filtering required. So I probably don't even need my capacitor here. All right. I apologize for how lame this example is, but it would seem like a fun thing to do in terms of comparing what the impact would be of throwing in a motor this large when I had a choice between AC and DC. But I think you got the idea here. By utilizing Scenario Manager, we haven't changed our primary design, and at any point in time we can go back to, let's go ahead and save this the way it is, go back to our Scenario Manager and open the base case, and we're back to the way we were. And while it's here, let's go ahead and look at our power flow. So we're generating a little over 1/4 megawatt. So the AC option really wasn't all that far off as far as energy consumption. At any rate, hopefully you got the impression that the scenario manager is useful in comparing what-if possibilities, and I welcome you to give it a try. Won't have time for questions today. Certainly, if you've got questions, please contact tech support at easypower.com, or you can send me an email, and we can help you get online with using the scenario manager. There are other tutorials online, as well as being able to use the online demo. And for any other questions, by all means, contact us at techsupport@easypower.com. We'll talk to you next week. Have a good week.